Rightio guys, today we look at equations with brackets. But before we start that, I think it's probably best if we go back and have a look at how we expand brackets when there's no equations. So this will go back to our previous unit on algebra. So if you're feeling particularly strong, you could pause the video here, have a go at these, and then I can go through my solutions. If you're looking at this right now and going, oh my gosh, can't remember before Easter, then I'll quickly run through how we do these ones. I'll just make the screen a bit bigger there. Actually, no, I won't do that because then I'll lose this. There we go. Leave that alone. Okay, so first things first, we just have to remember that whenever there's the sign's missing, obviously if there's supposed to be a sign there like a plus, a minus, or a divide by or multiply by sign, and there's nothing there, in mathematics that always means there's a multiplication sign there. So we just have to know that in that little spot there's a missing multiplication sign that's kind of just assumed. All right. So once we understand that that's the case, we know that everything in the brackets is going to be multiplied by 2. So I need 2 multiplied by x, and then I also need 2 multiplied by 3. So I need to multiply both things in the brackets by the number that's out the front, because it's not just x that's being multiplied by 2, it's both things in the brackets. So in other words, 2 times by x, 2 lots of x, 2 lots of x would be 2x. 2 times by 3, well, that's just 6. Okay? So if we look at the next one, once again, there's a missing sign there. We know that there's an assumed multiplication sign in there. So everything in the brackets is being multiplied by 3. Okay, so this one's got a little bit more of a trick, but let's just first deal with this first arrow. 3 times by 2x. When we multiply numbers and letters, we multiply the numbers first. 3 times 2, well, that's 6. And then we're just left with the x. And next up, we've got 3 times by negative 7. So once again, just think about the numbers first. 3 times by 7 is 21. And this 3 out the front is a positive. I know it's a positive because it has no symbol in front of it. Only negatives have to have the sign in front of it. Sometimes positives don't have to. So if I've got a positive times a negative, that means I'm going to get a negative. So my answer there is 6x minus 21. All right, going along to number 3. Once again, there's an assumed multiplication sign there, and we have to multiply with a number that's out the front by both of the terms inside the brackets. All right, so once again, let's just deal with this first one. 3x times by 5x, we'll deal with the numbers first. 3 times 5 is 15. X times x, we might remember back, we did this earlier this year. X times x is x squared. X times x is not 2x. X plus x is 2x, because 2x means 2 lots of x. X squared means x lots of x. X multiplied by x. Okay, so let's then deal with this second bit. So once again, we'll deal with the numbers first. The 3 times by a 7, well, that's 21. And we've still got a positive times by a negative, so that's going to be negative. And we've got these letters here, so x times by y is just going to give us x, y. Okay, and so that's those brackets expanded. And then finally, the last one down here, we have to expand and simplify. So I think the people who wrote this question, those people being me, the person who wrote this question, knew that we're going to have to simplify later on. So first things first, this minus 2 is being multiplied by all the things in the brackets. So I'm going to have minus 2 lots of everything that's in the brackets. Okay, so that number there isn't a 2, it's a minus 2. Every number owns the sign that's in front of it. The 14x is kind of not involved in the expansion. It's just sort of watching. We'll use it later, but for now we can just write it down again. Oh, sorry about that. We can just write that down. It's not involved in the expansion. It's separated by a minus sign. It's in a different part of the problem. So let's just deal with this. Minus 2 times by 5x. So 2 times by 5 is 10. A positive times by a negative, sorry, a negative times by a positive would give me a negative. And then I've just got the single x there, so that goes there. And then next up I've got a 2 and a 7. So 2 times by 7 is going to give me 14. They're both negative. So a negative times a negative is going to give me a positive. And there's no algebra involved in that one. So I've got that done and my expansion is correct. But now I can see I've got a couple of like terms here. This term here is 14 lots of x, and this term here is negative 10 lots of x. The final term there has no x's involved. It's a different thing. It's not a like term. So what I've essentially got here is 14 lots of one thing minus 10 lots of that same thing. So if I had 14 of something and I took away 10 of the same thing, I'd have 4 of that same thing left over, plus the 14 that's not a like term, and that's the end of that part. Okay, so that's all kind of stuff we've done earlier. I don't expect you guys to be 100%, or not every one of you to be 100% on it, but we have done that earlier. It's just those are there just to sort of remind us of where we were. Now today we just take that little skill that we've got there and use it in equations, and this is kind of, if you're still a little bit lost with expanding, that's okay. That's kind of why we do this. All right, so you get to work on being able to expand your brackets at the same time as working on your equations. Okay, so we'll just have a go and see what, it doesn't make much of a difference to what we've been knowing with equations. We still have all the golden rules of equations. Whatever we do to one side, we have to do the other, and we undo operations by doing the opposite. Those golden rules still apply. So let's have a look at this first one. So I've got 2 outside of 3x minus 4 equals 11. So I've got to get rid of these brackets really to solve this problem. So let's do what we were just doing in those revision questions. We'll get rid of the brackets by expanding. All right. So 2 lots of 3 would be 6, and then there's just an x there. And then 2 lots of minus 4. So 2 lots of 4 would be 8. A positive times a negative gives us a negative. So that's expanded the left-hand side. We've got rid of those brackets. However, we've still got that 11 there to deal with on the other side. That hasn't, the other side, although the golden rule applies of whatever you do to one side, you do to the other, there was nothing on the other side to expand. And expansion's not really changing the number as such, changing the value as such. We're not taking anything away, we're not adding anything on, we're just expressing the exact same thing that was already there in a different way. Okay, so now we've made that change and we're left with what is essentially a question we're kind of used to. So if we want to solve this, we just have to basically undo the operations until we're left with just a letter on one side and numbers on the other. So we undo them, we do undo our addition and subtraction before our multiplication and division. So I can get rid of that minus 8 by adding 8. But of course, whatever I do to one side, I have to do to the other. Those guys will cancel out. And I'm just going to be left with 6x equals 11 plus 8 is 19. And then next up, I'm going to say, well, I've got 6 times by x. The opposite of multiplying is dividing, so I'll divide 6x by 6. That'll get rid of that. But of course, once again, whatever I do to one side, I have to do the other. So I end up with x equals 19 over 6. Now, depending on the question, sometimes you might be asked to express that as a mixed numeral. So I know that 6 goes into 18 3 times, and there'd be 1 left over. So 3 and 1 6 left over. Most of the time, though, you'll probably find it's perfectly fine to have 19 over 6 as your answer. It depends on what's in the back of the book. I'm less concerned about that here. I'm much more concerned about the process. Okay, so the last example to go through, we've got 6 outside of x plus 3 minus 4x equals 32. So before we start dealing with anything else, let's just get rid of those brackets. We'll simplify that up. So we're going to multiply that 6 by x and by 3, because there's an assumed multiplication sign between that 6 and those brackets. So 6 lots of x would be 6x. 6 lots of 3 would be 18. And it's going to be positive because all the numbers there are positive. That minus 4x kind of isn't involved in the expansion. It's separated by that minus sign. So it just comes along as a passenger. And the 32 on the other side is unaffected by that expansion. We're not changing the value there. We're just rearranging it. And in the same way now, I can see that I've got myself a couple of like terms. 6x and minus 4x are like terms. So I can combine them up. Once again, this doesn't really change the value of this side. I'm not doing anything different. I'm just expressing 6x minus 4x in a little bit more of a simpler way. So 6 lots of something minus 4 lots of something would give me 2 lots of that same something. The 18 is unaffected. It's not a like term. And we didn't do any operation realistically to that left-hand side. We just simplify the left-hand side so the right-hand side doesn't have to have anything done to it just yet. But we've made that little change, we've done the expansion, and then we've made that little change, and now we're left with an equation that's much more like what we're used to. So the next thing we've got to do is, well, we've got to undo the operations on the left-hand side. So the opposite of adding 18 would be to take away 18, and of course that means we've got to take away 18 from both sides. So that'll cancel that out there. I'll be left with just 2x on this side. And 32 minus 18. Now, some of us will be able to just go, bam, I know what that is. All right? But I keep saying in class, and I want to demonstrate that when you're trying to do algebra and you've got enough to concentrate on with just the algebra, let your brain have a rest when it comes to the calculations. You can use your calculator. And we'll go 32 minus 18. Because it'd be really silly to mess that up and get that wrong when all of your algebra is correct. All right. Now, if you're feeling confident, that's fine, but it's perfectly okay as well to pick up the calculator to do those operations occasionally. All right. So now we're just left with 2x equals 14. That's 2 times by x. So the opposite of timesing by 2 would be to divide by 2. And of course, whatever I do to one side, I have to do to the other. So those 2's will cancel each other out. That'll leave me with just x on this side. And 14 divided by 2 would leave me with 7. And that gets me my answer. All right. Now, there's some questions there for you to have a go at. So question 2e, exercise 2e on page 73, questions 2, 6 and 8. Question 2 isn't an equation as such, it's just asking you to do that expansion. So you'll have to, like we did in the revision questions, you'll just have to expand those out, and they've sort of given you some of the answer already. Okay, question 6, we'll go down here to question 6. The questions in question 6 are a lot like the first example I've done here. So I might just write that there. So we might sort of put this here and say that's kind of question, I can't write today. Question 6 is those ones there. And these ones over here are like the ones in question 8. So we can use those 2 examples to sort of help us out with both of those questions. All right, have a go at those. Get done as many as you can. And I'll see you guys when I'm back.